Aaron, the resource teacher from Silver River Museum.
And I'm Alan, the visiting scientist from UF.
Behind us is the river. Did you know that the river has energy?
I had no clue, no.
All right, Alan, have you ever played the game Pooh Sticks?
Never heard of it.
All right, so we're going to take a look at this river and how we can prove that it has energy. So think about what you know about energy and what energy can do. And we've each picked a stick. You've got yours. You see they're very different. And we're going to drop them in the river. We're going to watch what these sticks do from one side of the bridge to the next side. All right, you ready, Alan?
I'm ready.
Let's give it a try.
All right.
All right, Alan. On the count of 3, we're going to drop our sticks, and then we'll run to the other side of the bridge and see who wins.
Sounds good, Aaron.
Whoever stick makes it wins. Ready?
All right.
1, 2, 3. I see your stick.
I see my stick.
You're the winner. All right, good game, Alan.
I win.
Yeah, you do. You win. So, moving water has energy, and that's what we saw with our game of Pooh Sticks. Energy has the ability to create motion or change, and we saw the sticks were moving. People have been using this river for thousands of years to move things. Think about the Native Americans in their canoes. If they were floating downstream with the movement of the water, they didn't have to paddle.
Loggers of the late 1800s, early 1900s would cut down cypress trees all along this river and would just let the trees float down the river.
And they were heading to the mills, right?
Of course.
Where they'd be turned to lumber. And starting in about the 1930s, rivers like this one were used to take the energy of motion, mechanical energy, to convert it or transform it into electrical energy. Take a look at this mill house at Juniper Springs. This is a great example. So let's take this lesson into the lab and learn a little bit more about how energy, like the movement of this river, can be transformed.
All right.
To really understand electricity, you need to understand what's behind it. Everything around us is made of atoms. And surrounding atoms, part of every atom, are tiny particles called electrons. Electrons are similar to magnets in one way. They have a charge. If you've ever played with magnets, you know that they can either attract each other or they can repel each other. No matter how hard I push, I can't get these two magnets together unless I flip one around. And that's because of their charge. So the electrons in an atom have a charge and they want to move. And whenever we can get electrons to all move together, we end up with electricity. So let's play around a little bit with some electricity and see if we can learn how moving water can be used to transform into electrical energy. And I've created what I think is a pretty good model of the mill at Juniper Springs. So you'll see I have a turbine, and I have the turbine hooked up to a motor. The motor came out of this toy RC car. And then I have a way to measure electricity. This is called a multimeter, and it will measure the amount of electricity coming out of this motor. So what I'm going to do is see if I can successfully take mechanical energy and transform it into electrical energy using this to measure. Now, because I'm in the classroom, I don't really want to use water to move this turbine. Air can also be used to turn turbines, and it is a source of energy just like water. I have canned air, so I'm going to use that, and let's see if we can generate some electricity from this turbine. So I am now reading about 25 milliamps of electricity. I wonder if that's enough electricity to light a light bulb. Want to give it a try? All right, so I have a light bulb here as well. And instead of my multimeter, I'm going to hook up my water wheel, or windmill, to the light bulb. It's not enough to light the light bulb. So my water wheel does generate electricity, but not enough. Let's explore some other ideas about electricity. Can electrical energy be transformed into other types of energy? Take a minute to think about that. So here's the first challenge. We want to take electrical energy and convert it to light energy. How would I make my complete circuit to get electrical energy to this light bulb? Now keep in mind, we saw that our water wheel does not produce much electricity. Do you see another source of electricity? The batteries are a great source of electricity. They have stored chemical energy in them, and that chemical energy can be transformed into electrical energy. So what happens if I hook up one of my wires to the light bulb? Nothing. What if I hook up both wires to the same end of my battery pack? Nothing. So while it looks like I have a complete loop with both of my wires connected to one end of my battery, electrons are not moving. So what if I take one wire on one side of my battery pack and one on the other? I have light. It worked. And so what's happening is my electrons, as soon as it's hooked up to the battery, the electrons in the wire get excited and start to move. And all of a sudden, I have a flow of electricity going through this pathway. And the chemical energy gets transformed into electrical energy, those moving electrons, gets transformed into light energy. But there's something else other than light energy. Think about the sun. It gives us not only light energy, but what other kind of energy? I can feel it. It's heat. This light bulb is warming up. So we've seen that electrical energy can be transformed into light and heat energy. What other type of energy can we transform it to? Maybe mechanical? So how could I get the electricity or the electrical energy using the batteries to my turbine? What would you hook up? Again, I have a couple wires here. Will one do it on one side? No, that doesn't work. Well, let's try what worked with the light bulb. What if we do two, one on either side of my battery? And there it goes. It's creating a nice breeze. In this case, my electrical circuit is again powered by the chemicals in the battery. They make the electrons conduct through the wire, and they go to this motor. And the motor has a tiny spinning part on it. When electricity is supplied, it will spin, and it will make my turbine also spin. I mentioned that birthday card that I had that sang a little song. And so I have the sound card from that birthday card, and I have a speaker. Now the sound card has built-in batteries, so I don't need to use these batteries. They have these little button batteries or watch batteries. How would I hook this one up? Let's give it a try. So I'm gonna try and just hook it up to the batteries like we did with the light. Can you hear that? I get a little bit of a static sound. So there's something happening, but it's not the song I want. So what we know about the sound card is it's a circuit board. It has lots of little pieces of metal connecting it. And so I've got to find the right place to complete my circuit on this circuit board. And so somehow these batteries are connected to all these little metal pieces on the circuit board. And if I connect this where the speaker should have been, I get sound. So electrical energy can also be transformed to sound energy, but only if we can get those electrons to move. So throughout these simple experiments, we've seen that energy can be transferred from one thing to another, but it can also be transformed from one type of energy to another. And this is a powerful understanding. Imagine the Silver River and imagine the amount of energy within that moving water that, should we choose, could be transformed into a clean source of electrical energy. And as we move into the future, our understanding of electricity, especially renewable sources of electricity, become more and more important. Thank you for joining me, and I hope you will join me during my live Zoom sessions where we will not only have a design challenge, but we will also have some special guests talking more about the concepts of energy.